Okay, this video tutorial looks at the mathematical strand of data representation and interpretation. And more specifically, we're going to focus on scatter plots and correlation of two variables. Okay, so what's the first thing you need to understand? Well, you need to understand basically what a scatter plot is. And a scatter plot is just a visual representation of two variables for an individual. So an example might be collecting data of height and weight of sports players from a particular team. So you can see here we've got our players. All right, I'd say this is a football team, given that it's got 18 players. We've got our height and our weight of each of the players. So that's our two variables. And then we've managed to put it on a scatter plot, which is here. An example of how we would plot it, well, this person out here is obviously the tallest player we've got. So that's most likely going to be player 1 because they have a height of 203 centimeters, right? And their weight is 106. So that's why when we come across here, this would be 106. We come down here, that would be 203. Therefore, this is going to be player number 1. Sometimes we're also required to read information from a scatter plot. So here's an example where we've got a scatter plot that shows the ages and work done by 5 employees. So the ages and the work are our variables. You can see we've got age and work. One of the variables on the x-axis and the other variable is on the y-axis. The first question says, which person is the oldest? Well, the oldest is the person who's furthest across the age. So this would be person number or letter E, right? Who has done the most work? Well, if we go as far as we can up the work axis, you'll notice that B and E have both done the same amount of work. So B and E would be our answers. And who has done the least amount of work? Well, the least amount of work would be the person who's lowest on the work axis, which is person A. Now, scatter graphs or scatter plots can be used to determine a correlation between two variables. So we've talked about how we use two variables and we put them on scatter plots, but we can actually determine a correlation. So what is a correlation? Well, essentially a correlation is just a measure of the strength of the relationship between them. Now, the relationship between two variables can sometimes be positive and sometimes be negative. If it's a positive relationship, the trend tends to go upwards. If it's a negative relationship, the trend tends to go downwards. Right? And the strength of the relationship, or the correlation I should say, is really determined by how close your scatter points are. Right? As you can see, the strong relationship or the strong correlation has scatter points that are very, very close together in a line, whereas our weak correlations have scatter points that are quite far apart. Okay, you're now going to have a go at a practice question. If you could pause the video, have a go at the question. Once you think you've got the answer, continue with the video and we'll check and see how you went. Okay, so here's the question. Alexander researched the elevation above sea level and mean annual temperatures of 12 cities around the world, and the results are given below. So you're required to draw a scatter plot of the data, and then you describe the relationship, so the correlation. Please feel free to pause the video here, answer the question, and when you think you've got the right answer, continue the video and we'll check and see how you went. Okay, so let's see how you went. Our scatter plot should have looked like this, where you've got your temperature on the y-axis and the elevation on the x-axis. You can see that the scatter points are linear, okay, in a negative correlation because they're heading down, okay, so they're going downwards, and they're not exactly tightly put together, but they're also not very spread out. So we would call it a moderate, okay, moderate negative correlation.